Alright, take a look at number 1. We're told that we have our u. And our u is down here. So now I need to find what du is equal to. So what's du equal to? Times dx. So I got 20x to the 4th dx. Do I have that? Yeah, I have my dx, which is right here. So that's my dx. So if I go back and I replace everything, I have the integral of du over u. Because u is in the bottom and the du goes up in the top. Now we go back and we look at our rules. And do we have a rule for this? Well, do we know a derivative that's 1 over u? Natural log, right? So this is going to be the natural log of the absolute value of u plus c. So this is the natural log of 4x to the 5th plus 3 plus c. So you need to be able to apply these to different rules and kind of look past just what the normal rules are. Now, here's the thing. When we take the absolute value, or when we take the integral, we need to take the absolute value of the natural log just to make sure that it's a positive number. Because if we're working with it originally, we can always ensure that it's a positive number. But now we don't know if it's going to be positive or negative. So by making it absolute value, we ensure that it's an absolute value, that it actually works, because natural log, you can't take the natural log of a number. So that's why we need the absolute value. So here's something that we might want to add to our list of rules. Absolute value of du over u is equal to the natural log of the absolute value of u plus c. You might want to throw that one in there somewhere. And I wanted to see if you guys can do some extrapolation and look at some of the derivative rules and the integral rules and see if you can kind of work backwards a little bit. Do some problem solving. I don't know, take out what the answers were in the online. Alright, questions on that? So now we've developed a new rule. 1 over u du is going to give us natural log of absolute value. So I have my u. My u is up here with the e, which is what we want. Whenever we have e to some crazy power, the crazy power is going to be u. The crazy power is going to end up being u. X. Alright, now, do I have 12x? So I have 36. So how do I make 36 into a 12? Times 3? That'd be 102. Divide by... Now, what's the integral of e to the u? Yep. So it's going to be 3 times e to the u plus c, which is 3 times e to the 4x cubed. That, you know what, I have to solve a problem, and I have to continuously fight and fight and fight and fight to solve that problem, which might mean you have to work. You have to look stuff up. You got to look at other things. You got to make some guesses. You got to look at the answer and see what they got as the answer, and then maybe kind of work backwards from there to understand why they did it. It's called reverse engineering. U.S. military does that all the time. And then plus a c, and then you can rewrite it as 4 over the natural log of 3 times 3 to the 5x to the 4th plus minus 2 plus c. So this goes to rule number 4. No, it was a different rule. All right, now for number 4, we're given all right, now in here, what do you think the u is going to be? Do you see something and then you see its derivative? Or something that, remember what we said yesterday? When we look for either the most complicated thing or we look for something and then something that could possibly be its derivative.
X cubed can be the derivative. Actually, 12x squared is the derivative of x cubed multiplied by 4.
Right. You have x cubed and you have an x squared. So you have something and then you have something that could possibly be its derivative. So that's, for u, we'll take what's on the bottom. X cubed plus 2. Yes. Yes. That's the natural log stuff. That's only because it's all natural log stuff in here. Oh yeah, it could be anywhere. So now du is going to be 3x squared dx. Now, if I needed 3x squared, that 12x squared is really what? 4 times 3x squared. So can I take that 4 and move it out front?